the next operation we're going to look at with matrices is multiplying matrices. In order to multiply matrices, they cannot be the same size, except for few circumstances. Adding and subtracting, they have to be the same size. For multiplying, unless they're square matrices, they cannot be the same size. We will not be able to multiply them. And it is very important the order as to which we multiply them, and I'll show you with a case in a little bit. So to begin with, before we can even start trying to multiply together, we need to take a look at what are the size of each of these matrices. So my ABC matrix, this first matrix here, number of rows, 1, number of columns, 3. So it's a 1 by 3. Again, you have to write it in that exact order, rows by columns. The second one, number of rows, 3. Number of columns, 1. This is really, really important. The only way I can possibly multiply these together is to look at the two inside numbers. These two inside numbers must be the same in order to multiply them together. If they are not the same, they cannot be multiplied. You can't do the operation. Then, when we added and subtracted, whatever size we started with, that's the size we ended with. Not the case for multiplication. The outside numbers is the size of the matrix. So my resulting matrix, after I do all of the work and multiply it together, is a 1 by 1. It's one element in there. So that's the process as to how do you figure out if you can multiply them together. Next, we're going to get into how do we multiply them together. So here's our specific example. I have an A matrix and I have a B matrix. When we name our matrices, we usually use capital letters. So I asked you to find AB, which means I want you to multiply A on the left and B on the right. It has to be in that order. When I multiply, you multiply an entire row by an entire column. And within that entire row and column, you add corresponding pieces. So for instance, I have 1, 2, 3 across and 2, 7, 1 down. I multiply the entire row by the entire column. So when I do this, I get a specific element. This one is the top row. This one is the left column. So in my matrix, it's going to be in the top left spot. Now, I jumped ahead a little bit. Let's do the size of these so we know we can multiply them together. My A matrix, number of rows, 2. Number of columns, 3. My next matrix is a 3 by 2. My inside numbers are the same, which means my resultant matrix is just going to be a 2 by 2. It's going to be a nice square matrix. So there are 4 different spots in this matrix. I just described to you how you find one of them, or where its location at least is going to be. So what I'm going to have to work on now is how do I actually get to that spot. So I'm going to show my work for all of this along the way. So I take the first element, this 1, and multiply it by the first element, the 2. Plus the second element, 2, times the second element in that column, which is 7. Plus third element times third element. That just gives me the top left spot. I'm going to slide this over. What we just found by doing all of that work is that number goes right there. Okay, so take a moment, do the math. And you should get 19. Okay, now that was my top row, left column. So now I'm going to do my top row, right column. So top row, right column. So in my box, top row, right column is this spot here. So I'm going to go through the exact same process we did before. First element times first element. 1 times 3. Plus, again, we add within each of them. 2 times 2. Plus 3 times 4. Again, that gives me my top right space. And it also has to happens to be 19. So I have my top row completely done. Because in my A matrix, I use my top row for each of the individual columns. I've multiplied that row by all of the possible columns that are there. So now I have to do the bottom row by each of the columns that are there. So now I'm going to do the 4, 5, 2 and multiply it by the 2, 7, 1. See if you can pause it and go through and do it on your own and then play it. See if you got it right. So 4 times 2, first element times first element, plus second element times second element, plus third element times third element. And when I do that addition, that's again the bottom row left column. Bottom row left column is right there. And that ends up being 45. The very last one is the bottom row right column, which is over here. So lastly, it's first element 4 times first element 3, plus first element 5, or second element 5 times second element 2, plus third element 2 times third element 4. That again was the bottom right. That number is 30. So that is my final answer to this matrix. All of this work found my answer, which is this matrix here. This is what I was trying to get you to find. That's all I was trying to do, is go through, do the multiplication to get that matrix. Multiplication, in my opinion, is one of the more difficult operations to deal with in matrices. With that said, it's a huge part of what we do when we use matrices to solve. So next thing I'm going to have you do is I'm going to have you find BA. If you notice, my A's and B's were the same. I know it's kind of small here. A and B matrix are the same. Now what I want you to find is B times A, which means when I want B times A, B comes first, which means my B matrix comes on the left-hand side, and my A matrix is on the right-hand side. That is important, and I think visualization is important for you as well. Because now if you look at this, what's the size of my B matrix? My B matrix, rows 3, columns 2. My A matrix, rows 2, columns 3. Can I do it? Yes, two inside numbers are the same. Outside numbers happen to be the same as well. They don't have to be. Okay, it's just the resulting size. My resulting matrix is going to be a 3 by 3. So this matrix is going to have numbers in each of those circles. Same matrices I'm multiplying together. I'm just multiplying them in a different order. Are they the same? No. That's part of the reason you have to be very careful when you're multiplying matrices together. You have to make sure you have them in the correct order. That is one of the biggest mistakes I probably see when we multiply matrices together. Not even the difficult part to it. Just not realizing, oh, I have to have this one on the left-hand side. I have to have this one on the right-hand side. So what I want you to do is I want you to go through, do this multiplication, get this practice down. So that way you can kind of see, okay, I'm doing it right. I'll show a little bit of my work along the way so you can at least see the process that you're going through. So maybe if you make a mistake, you can catch that mistake. I will say, though, if you do start making mistakes in multiplying them, you're probably going to make the same mistake over and over unless you catch it. So this is one of those things that you want to find your mistakes because you're probably going to do the same types of mistakes again and again. You can have negatives in there as well, so be careful when you're doing your addition. If there's a negative in there, that you get that straight. So here's the work that sets everything up for you. If you notice, one way I quickly check this is if you look vertically, because we're continually multiplying them by the same elements, those go there. And then the other thing that you may notice is that there's a 2 here, a 2 here, a 2 here, a 3 here, a 3 here, a 3 here. Because again, those rows and columns, it's in the same spot. They should be located in the same area. This is a quick check that I make just to make sure I didn't accidentally make a mistake somewhere along the way. So my answer then to this problem, that 3 by 3 matrix, is the matrix 14, 19, 12, 15, 24, 25, 17, 22, 11. And that's the answer to my matrix. As you saw earlier, and hopefully now as well, the answer to each of these is very different. The first one, when I multiplied A times B, it was a 2 by 2 matrix. This time it's a 3 by 3 matrix. Very different numbers that appear in there as well. So very last thing I want you to do is I want you to multiply these two together. Again, same type of concept that's taking place. First, what I want you to do is I want you to pause this. I want you to write the size of the matrix. Then I want you to find what your resulting matrix is. Make sure it's actually making sense. Keep in mind that you're going to have some pluses in some of them, and others of them are not going to have them. I will show my solutions to each of these along the way. Try to do these without my help, as in when we tend to use variables, it tends to get a little bit more difficult. So I know my sizes right away from the beginning. My first one's just going to be a 1 by 1. There's going to be one element in there. There's going to be stuff that's added together. My last one is going to be a 3 by 3. There's 3 rows and 3 columns. So now I'll give you your answer. So I multiply the entire row by the entire column. Here's my entire row. Here's my entire column. Within that row and column, I add elements. So it's AD plus BE plus CF. That is the answer. That is my 1 by 1 matrix. Again, that's just adding together. Those letters could be numbers, and I would just have a single constant as an answer. This compares to the opposite one, or the other one. An entire row, one element, times the entire column. That top element is just AD. Doesn't matter which order you write it. AD, DA, doesn't matter. And then I multiply D times B. And then B times C. So I took care of my top row. Now I go to the middle row. And I keep going. And there's a solution to this 3 by 3. So take some practice, go through multiplication. You need to get some good practice on this to kind of give you that extra confidence because it is a tough concept to work through.